Okay, we're going to start with exercise 4.2. This is a asphalt road with a 6-inch curb and a sidewalk. So this is the center line of your road. It's asphalt, so your curve is going to be, or your contour is going to be curved versus a V shape. V shape would be concrete. A curve is asphalt, and it's going downhill this direction, so your curve is going to be this direction. You'll see this as we draw. We're going to do this first contour, then you're going to do the rest of the contours, which are all going to follow the same steps. So once we do one, you should be fine. So we have the center line of the road, and it slopes on these arrows here, slopes this way and this way. And then the sidewalks on each side. This is curb, curb, sidewalk, sidewalk. Sidewalk slopes 2% to the gutter, or the curb goes over the curb into the gutter, and then will flow this way downhill that way. So your gutter, you would have a curb and then a gutter right here. So let's go ahead and get started. 1/4 inch per foot. That is the same to figure out what that is in a percentage, or a percentage you would do. It's 1/4 inch equals 1/4 inch per foot. So divide 1 divided by 4 equals, because there's 4 of 4, that's 1/4 of an inch, so there's 4 of those, right, in an inch. So divide that. 1 divided by 4, 1 divided by 4 equals 0.25 divided by 12, because there's 12 inches in a foot, right? So divide that by 12 equals 0.0208. So we're just 2%, right? We go to the hundredth, nearest hundredth. So that's 1/4 inch per foot is the same as 2%. I think they just wanted you to understand how those 2% and 1/4 inch per foot, same thing. All right, so we'll go ahead and get started. What's the very first thing we have to do? We always have to start with the known elevation, which is 14.7, right? And it's going uphill this direction, so we're going to go from 14.7, we're going uphill, so we've got to get to contour 15, the closest whole contour. So 15 minus 14.7 is 0.3. So that's our vertical that we've got to go to get to contour 15. What else do we know? We know our slope. It's 0.3. So we know our slope is 3.3, which is 0.033. Same thing as 3.3. What we don't know is our horizontal. We're trying to figure out horizontally how far away 15 is from 14.7. So this horizontal equals vertical divided by slope. So vertical divided by slope is 0.3 divided by 0.033. For that, we get an answer of 0.3 divided by 0.033 equals 9 feet. 9.09. That equals 9.09. We're just going to call that 9 feet. So you'll measure at 16 scale here. Line that up. Half an inch is 8 feet. 8 feet, so 9 feet. We're going to go just over half an inch to right here. Get my glasses out here, it's easier. So this is, and we put it on the uphill side. So contour 15 starts right there. Now, we know that this slopes down this direction, and it slopes down this direction, so we only have to do one side, and the other side will be just the same. Let's just draw a guideline across here. I'm just drawing a really soft guideline. So what we've got to do is go downhill this direction. See, downhill at 2%, quarter inch per foot. So with this, we don't know how far we're going to drop vertically, right? We know this elevation, we don't know this. But we do know the slope, 2%, or 1/4 inch equals, or 1/4 inch per foot, 2%, and we know that the distance, our horizontal distance, is 2, 4, 6, 8, 9, 10. So this is 10 feet. See that? 2, 4, 6, 8, 10. This is a 20-foot wide roadway. So 10 feet. So our horizontal is 10 feet. Let's figure out, we're going to figure out what our vertical equals horizontal times slope. We know that our horizontal is 10 feet, right? That, because we just measured that, 10 feet. And we know that our slope is 0.02, which is the same as a quarter inch per foot. And that equals 10 times 0.02, 0.2. So it drops vertically 0.2, drops 0.2 feet downhill. Right, it's going down this crown and it's sloping this way, going downhill 0.2. So we subtract 0.2 from 15 and we get, at this point right here, and this is, remember, this is the bottom of the curve. This is a 6-inch vertical curve. So the bottom right here would be 14.8, right? 14.8. I just took 15 and I subtracted 0.2 to get 14.8. Now, if we went downhill 0.2, now we've got to go uphill, right? If we go downhill, we got to go uphill to stay on 15. So now we've got to go uphill that same distance, 0.2 vertically. So what do we not know? We don't know horizontal, how far we've got to go, but we know that our calculation is horizontal equals vertical divided by slope. We know that the vertical, we just drop 0.2, and we've got to go uphill, right? Because go downhill, got to go uphill. Uphill is this direction. So our vertical is 0.2, and we've got to divide that by our slope. And our slope of the road going this way is 3.3, or 0.033. And that equals 0.2 divided by 0.033 equals 6 feet. 6.06. So we're just going to call it 6 feet. So what we've got to do is go 6 feet on this side, 2, 4, 6. And we got to go 6 feet on this side, 2, 4, 6. Right? So that's our contour. And remember, it's arched, so now we've got to draw from this 15 to this one, but instead of straight, we kind of want to do an arch. So I like to just kind of dash it in really gently, just to guide me. And then I'll draw it in hard, like that. So now, this is an asphalt road, and that's where I was saying it's curved instead of the V shape of concrete. Now, if we went down 0.2 and we went up 0.2, now at this point we're at the bottom of this 6-inch curve. So we've got to go up this 6-inch curve. If we're going to go, or we go down, we go up, and now we got to go down. So it's always alternate from, if you go down, you got to go up, then you got to go down. And we've got to go from here 6 inches to get to the top of this 6-inch curve. That's why we've got to go 6 inches instead of 0.2. So now we know how far is that. Our vertical, 6 inches, which is 0.5, right? Half a foot, because they tell us right here, 6-inch curve. So we've got to go 6 inches, or 0.5, and we've got to divide that by our slope, which slope of this road is 0.033, 3.3%. That equals 0.5 divided by 0.033, 15 feet. So, not quite, this is 16, so 15 is right there. So, 0.5 divided by 0.5, we got to go 0.5, that's 6 inches, divided by the slope of the road to get us back up. So we've got to go this direction because we went down, up. Now we're going down, see, downhill on this slope. So if we go 15 on each side, that means we have a slope going like this. Our contour, I mean, going this direction. So now you can see we've gone down 0.2, we've gone up 0.2, now we've gone down 0.6, half a foot, and now we're at the top of the curb. And now from the curb, front of the curb to the back of the sidewalk, it's all 2%. The sidewalk's 2%, the curb's 2%. It all drains at 2%, drops over the curb and into the gutter of the street. So we'll just draw a guideline across here, kind of like that. Now we went up, and now we've got to go, or we went down, up, down. Now we're at the top here. We're going to go up, right? Because this is sloping this way, so we've got to go up at 2%. And if you measure this, it's a 6-inch curb plus a 5-foot sidewalk. So it's 5.5 feet total from the edge of the sidewalk to the curb, front face of the curb. So we know our horizontal is 5.5. And what we don't know is our vertical. We're trying to figure out our vertical, which is horizontal times the slope, with slope 2%, 0.02 equals 5.5 times 0.02 equals 0.11. 0.11 feet. So it goes uphill 0.11 feet. So if we go uphill 0.11 feet, we gotta go downhill 0.11 feet. Okay, so the thing is, so we got to go at a different, we're looking horizontally, how far do we go? Vertically, we got to go, we went up, now we got to go down 0.11 feet vertically. We don't know the horizontal, we got to divide that by the slope. Slope of this road going that way, 3.3, 0.033 equals 0.11 divided by 0.033 equals 3.33 feet. So if you measure 123.33 roughly right there, on this side 123.33 roughly right there, and then you just connect these like this and like connect the dots. So what we have here is the water flowing this way, right? Because it's going downhill this way, and it's perpendicular to this curb, or to the curve of the contour, so it's going this way. The water's flowing that way and that way, right, towards the curb or in the gutter, and then the water flows this way downhill, down the gutter. The water goes in here into the gutter, and then from the sidewalk, here you go, it's flowing this direction. So water's going into the curb, over the curb, into the gutter, across the street, into the gutter, and then down the street. So now you just have to do these same steps to continue. You need your 14, or we're going uphill, so now we need our, right, be our 16, 17, 18 foot contour. Same principle. You just know that this, now instead of doing 0.3, which we did here, which was this vertical from 14.7 to 15, now it's going to be 15 to 16, so it's a full foot. So now it's 1 foot is going to be our vertical, right here, 1 foot, divided by, now your slope, boom. So just repeat these steps that I just showed you, and that's how you grade out this road.